Welcome all of you who are following news of the Global Energy Association. Today we are at the National Research Nuclear University Moscow Engineering Physics Institute and are about to talk to Dr. Georgy Tikhomirov, Deputy Director of the Institute of Nuclear Physics and Engineering. Dr. Tikhomirov, where else but here should we discuss the prospects for the nuclear industry development? Today we are going to talk about such a promising technology as the closed nuclear fuel cycle. How can you describe it?
The closed nuclear fuel cycle is a very important step in the development of industry. It is the case when we recycle fuel and reuse it. I mean that unfortunately, the nuclear power industry hasn't got great future without a closed nuclear fuel cycle because the reactors operating today are thermal neutron reactors able to use 1% of the uranium available in nature, so their fuel base is limited. A closed nuclear fuel cycle actually opens up access to the remaining 99% of the energy contained in uranium.
What do you think? Is there any possibility for a complete transition to a closed cycle in Russia and, looking more broadly, worldwide?
I think it's a distant perspective, but what does distant really mean? Is 100 years a lot or not? I mean, we've got enough uranium for thermal reactors for 100 to 150 years, so in my opinion we will switch over to a closed nuclear cycle mostly in the coming century, but the start will take place in this one.
Now, speaking about economics, in the end, the closed cycle is more expensive than the open one. What are the ways to reduce the technology costs that are available right now? Or is it too early to talk about it?
Well, I think economics is thought about and remembered today. I wouldn't say that a closed nuclear fuel cycle is cheaper or more expensive than an open one. Why? Well, it's too early to talk about the cost when the technology is not yet implemented. Moreover, speaking of the open nuclear fuel cycle, a real problem there is storage of radioactive waste and the spent fuel assemblies. If a reactor operates in an open cycle, the fuel assemblies are not recycled and have to be disposed somewhere. The disposal cost is sure to make electricity more expensive. The way we recycle fuel assemblies in the closed nuclear fuel cycle solves this problem. Of course, today, economic calculations take into account all the expenses: design, construction, operation and decommissioning, and this is probably correct for all types of energy generation. Concerning the solution of the waste-related problems, in that sense I do hope that the closed nuclear fuel cycle technologies would be competitive with the other ways of electricity production, and this is our goal.
We often hear discussions on how much oil and gas we have left. What about the uranium to be used in reactors?
This is a very good question, and I'll explain why. Because if we consider, the reserves of hydrocarbons and uranium, I mean, only the uranium-235 used in thermal neutron reactors, this is only 6% of the total energy reserves of the Earth, including coal, oil and gas. Once we turn the picture over and include the closed nuclear fuel cycle, we consider that 85% is uranium and only 15% is coal and gas. Therefore, considering the current pace of energy consumption and thinking about oil, gas and coal, of course, we must say that the reserves are limited because the reserves that are explored and developed nowadays will be enough for 100 years. Coal would last longer. There have already been periods in the history of oil industry when annual consumption exceeded the new reserves explored the same year, and the finish line was already there. Of course, this stimulated the development of new fields, stimulated the technology of extracting hard-to-recover oil. But at the same time, oil can be used in a different way. And if we also recall the problems of environment, the problems of climate change, then of course we need to abandon fossil fuels. From this point of view, I'd say globally nuclear energy should come to the rescue. So this must be done.
Speaking of the related fields, it was just 10 minutes ago that we were discussing research byproducts. What can you tell us about that?
Well, I think that in general, nuclear and thermonuclear technologies are also valuable because those are high-class engineering, so they give rise to a lot of interesting side things. Among them are plasma engine, plasma processing of materials, and products exposed to radiation accompanied by changes in their properties. Judging from this point of view, I think the more young people are involved in it, the better the world would be in terms of various applications. I say so as a person dealing with the nuclear industry industry and nuclear technologies all my life. If you look back at that great Soviet nuclear project, and not only that one, there are a lot of applications, including laser technology, rapid development of mathematical methods for superconducting, and so on. All of them are the products of thermonuclear and nuclear research.
What kind of research and development are at the cutting edge of science now?
You mean in nuclear technology?
Yes.
In my opinion, a closed nuclear fuel cycle and small-scale power generation. I believe that our academician Lomonosov project is the first breakthrough, which enables all the countries to analyze and develop their projects. There are lots of them. Thermonuclear research is supposed to put an end to that race about possibility to obtain energy from thermonuclear fusion and create a demonstration nuclear reactor. Laser technologies. Anyway, all this is still highly important for modern modeling. Quantum technologies, they are close to our sphere because it is splitting into atoms, and the use of atomic radiation for various applications there. So there is plenty of work to do. Another big direction is biodirection. We should remember biotechnology, where we also use, for example, various sources, both neutrons and X-rays, for structure analysis, which helps us come up with new medicine, understand the processes in our body, so all this is also extremely important.
What is your forecast for the nuclear power development in the context of, let's say, the balance of the future?
To be honest, making predictions is a difficult and unrewarding task, so I'd like to believe that the nuclear power share in the total volume of, say, power production should increase. I say so because in recent years it has been declining a little bit, to our regret, but I also think we must break this and reach 20% by the 2050, I mean the total energy production in the world. It is an ambitious task, but I believe it is within our power to do so.
Thank you very much.